So today we are going to discuss the stone game 4, and this is today's daily challenge. So I will directly explain the question, what it is. So there are two players, one is Alice and another one is Bob. There are actually many questions related to Alice and Bob. This is one of them. So what happens? There is a pile. There is a pile of stones. So there are so many stones, and which is n, right? So if it is one, then only one stone is there. If it is four, it's four stones are there. And in any turn, Alice or Bob can only take square number of stones out of this pile. Means only one stone, two stone, not two, four stone, 9, 16, and so on, or 25 and so on. Only this stone they can take from a pile. And if they are taking these many stones and there is no stone remaining, then they are winning the game, right? So for example, if this is a pile, only one stone is there, so Alice can, and most important thing, Alice is starting the game, right? So Alice is starting the game. So if there's only one stone, he will pick one and he will win the game. If there are four stone, he can pick four also, he will win the game. But the problem is if there are only two stones, so he can pick one, but in the next chance, Bob will pick one and he will win. And they are playing optimally, right? Means Alice will move that particular move, which will lead him to win the game, right? So that's the strategy. So this is a DP problem, and I will explain how to think this particular problem. So what you can do, for example, you can understand it by like, if there are like how many possible n is there, right? So there are 10 to power 5 is the limit. So for example, if your n is 4, right, and you are creating the array of 4, right? So think in the way, if Alice is picking 1 or 4, right, 1 or 4, so you have to check, if Alice is picking 1, then is there a chance of winning the game? If Alice is picking 4, is there a chance of winning the game, right? So you have to check if for each possibility, that is there a chance of winning the game. For example, n is, I will take a bigger number, 10. So how many possibilities are there for Alice? He can go for 1, he can go for 4, he can go for 9, but he will go for that particular move which will lead him to win the game. Now think another picture. If Alice will pick 1, then for Bob, there are 9 stones in this, right? Because he will pick 1 and there are 9 remaining. And the same thing Bob will do. He will pick those many stones which will lead him to win, right? He can pick 1, he can pick 4, he will pick 9, right? So this is leading him to win, so he'll pick that. So what you have to do, you have to check every possible case, right? Every possible case. He can pick 1, he can pick 4, he can pick 9. Now you are thinking, if you will check every possible case, it will become exponential. No, you will store the result also. For example, you are you will store the result based on the number of piles, and you will not attach any name. I will explain what I'm trying to say. So if there are 10 piles, right, and this is Alice chance, and if some result is coming for these 10 piles, like in the end you will get something, right? So in, if any of the case will lead you to win, you will store it as a win because you will move that particular move, right? So you will store the result as win. Means if I am moving 4 and it's leading to win, then I will say that the result for Alice is win only, because he will go optimally only. And the result you will store for this particular value, right? 10. That result for 10 is coming because 10 piles are there and he is moving 4, and result from internal function is coming. So what you will do, Alice will select 4 out of it, then 6 are remaining, then you will call the same function for Bob. Okay, so what will happen? There are 10 stones, Alice is picking 4, So 6 are remaining. Then you will check if Bob can win this game. If the Bob cannot win this game, then Alice is winning by choosing 4. So that's the strategy. So you will check every condition, and whatever the result will come, you will store that to particular n. So what will happen? There can be some repetitive cases. How? For example, you are selecting 4 out of it, then it's becoming 6. And again, if you are like selecting something and it's coming like it's coming 2 and some kind of like, now what will happen? You are selecting 4, right? And it's coming 6, then you are selecting 4 again, it's coming 2. So 2 is 2 you are calculating right now, means the result will come from here, right? So you will store it here. But you can do one more thing. You can select 4, that's fine, but you can select 1 1 1 1 1 1 1. So 2 will come again. Now you will again calculate the result for 2. No, you have stored it right earlier. So that's the DP. You are storing the results and using it again and again. So for some particular value, for some particular I which is greater than 1 and less than n, less than equal to n, greater than equal to 1, for particular I, you will touch that particular I only once, because when you calculate it, you will store it, and whenever again you will need it, you will get the value from it, the stored value, and use it, right? So I will explain in the coding section, that will be helpful actually in this particular question. So how I'm doing. So what I'm doing, so I'm using one helper function. So for example, if some n is there, so I'm creating a DP array of size n plus 1, and I'm using the helper function. So what's happening? If DP of n is not, means initially it's all the DP values are 0, right? So if DP is not equal to 0, means I have calculated it earlier, so use that result, right? So 1 for me is true and 2 for me is false. So that's the meaning. So I will use the earlier result. If earlier result was 1, use the true. Earlier result was 2, use the false. Otherwise, if it's not calculated earlier, I will calculate it now. If n is 0, that means you have to return false. Why? Because the one who played last time already won the game, right? Means if Alice played last time, then he will call the function with value 0, and 0 means he already selected all the piles, right? So he will win the game. So that's why I am returning false in this particular. For example, there is only one stone, right? And Alice selected it, so he will use the helper function again with 0 stones, 0, literally 0, nothing is there. So means that means he won the game. So if I will return false from here, so I am actually here, I am taking the negation of it, means because Alice played this game, so Bob is the next one. So if Bob loses, then only Alice wins. That's why I'm taking negation. If any of the move which Alice plays, and in that move Bob loses, that's why any, if any of the move is like that, I will return true, means Alice is winning. So that's what I am doing here, returning true. Otherwise, in the last, if there's no such move, then I will return false and store the value in DP, that false, and storing here in a true. So this is a thing, and actually I will suggest that try to solve it yourself, so that you will understand it deeply and it will help for long run. Yeah, thank you for watching this video, and if you need any help, please ask me in the comment section. I will surely do that.